Hi, I'm Charlotte, and today I will be presenting my research proposal on the impact of trait anxiety on nicotine self-administration among adolescent rodents. Vaping and anxiety are pressing issues affecting adolescents, with growing evidence of a significant association between these concerns. In 2023, Clendon and colleagues found that individuals aged 16 to 24 with heightened anxiety were 30% more likely to have recently vaped compared to their non-anxious peers. This highlights the importance of understanding the interplay between anxiety and vaping, which may form public health strategies and interventions addressing these concerns. Research by Aries and colleagues found that repeated nicotine vapor inhalation in adolescent rats increases the likelihood of actively seeking nicotine vapor in adulthood. This suggests that vaping during adolescence results in lasting sensitization and a greater frequency of nicotine-seeking behavior later in life. Additionally, the study observed significantly more pronounced extinction bursting, a temporary increase in previously reinforced behavior when the reward is removed in rats that received nicotine vapor compared to the control group. These findings underscore the importance of reduced adolescent vaping to prevent long-term nicotine addiction. Another study by Dean Lee and colleagues found that rats with high trait anxiety, which refers to an increased tendency to experience anxiety, self-administered more cocaine than low trait anxiety rats. This finding indicates a clear relationship between high anxiety and cocaine self-administration. However, similar effects were not observed with heroin, another addictive substance, suggesting that the impact of trait anxiety may vary across different substances. Now, given that trait anxiety affects cocaine self-administration in rodents, it is plausible that it may also influence nicotine self-administration, as both nicotine and cocaine share addictive properties and impact the brain's reward pathways, including the VTA. However, we cannot draw conclusions based on this alone, especially since trait anxiety does not impact heroin self-administration. To address this gap, the current study aims to investigate the role of trait anxiety in nicotine self-administration among adolescent rodents. It is hypothesized that high trait anxiety rats exposed to nicotine will exhibit high levels of self-administration and more pronounced extinction bursts compared to controls. Understanding the interaction between trait anxiety and nicotine vaping during adolescence is crucial. If trait anxiety enhances nicotine self-administration and results in more pronounced extinction bursts, this could reveal vital insights into how anxiety contributes to nicotine addiction. Such findings could inform targeted interventions to reduce vaping among adolescents and address risk factors associated with developing severe nicotine dependence. The method of the proposed study will use 25-day-old Sprague-Dawley male and female rats in a 2x2 factorial design. The independent variables are trait anxiety, with rats being classified into low trait anxiety and high trait anxiety. The next independent variable is nicotine exposure, with rats randomly receiving nicotine vapor or control PG vapor. The dependent variable is the rate of lever presses during self-administration and extinction phases. On postnatal day 25, rats will be assessed for baseline anxiety using the elevated plus maze and social defeat model, with classifications into high trait anxiety and low trait anxiety groups. From postnatal day 31 to 40, rats will be trained to self-administer nicotine or PG vapor in operant chambers. Each response will deliver a light cue and a 1-second puff of vapor, followed by a 20-second timeout until a stable baseline of less than 10% variation in active lever presses across 3 consecutive sessions is achieved. From postnatal day 38 to 67, rats will undergo continuous self-administration, with access to nicotine 6 hours per day. From postnatal day 68 to 73, the lever presses won't result in vapor delivery, but will still trigger a light cue. Lever presses during self-administration and nicotine and extinction phases will be assessed using an ANOVA and repeated measures ANOVA to compare the groups and assess extinction bursting. For the expected results, Figure 1 depicts the predicted number of lever presses for nicotine vapor across the self-administration phase. It is expected that rats exposed to nicotine vapor will exhibit significantly more lever presses compared to those in the control PG vapor group. Additionally, high trait anxiety rats are predicted to demonstrate significantly higher rate of lever presses compared to low trait anxiety rats. This suggests that nicotine vapor leads to higher self-administration, indicating addiction development with a more pronounced effect in high trait anxiety rats. Figure 2 depicts the predicted number of lever presses for nicotine vapor across self-administration and extinction phases. Rats receiving nicotine vapor are expected to gradually increase lever presses during the self-administration phase, with high trait anxiety rats demonstrating significantly higher rate compared to low trait anxiety rats. Upon nicotine cessation, nicotine-exposed rats are expected to exhibit an initial spike in lever pressing, indicative of extinction bursting, followed by a gradual return back to baseline levels. This effect is more pronounced in high trait anxiety rats, who maintain higher rates of lever presses compared to low trait anxiety rats throughout the extinction phase. Control rats, both high trait anxiety and low trait anxiety, are expected to maintain consistent lever pressing throughout both phases with no significant changes. The anticipated findings highlight the role of trait anxiety in nicotine-seeking behavior. High trait anxiety rats are expected to show significantly higher rates of lever pressing for nicotine vapor during the self-administration phase compared to low trait anxiety rats, supporting the hypothesis. Deline et al. Found that rats with high trait anxiety self-administered more cocaine compared to those with low trait anxiety, suggesting that anxiety can influence drug use. Given the similar addictive mechanisms within the VTA shared by nicotine and cocaine, the current study expects a similar result to Deline et al. Specifically, that high trait anxiety rats will show significantly higher rates of lever pressing for nicotine vapor during the self-administration phase compared to low trait anxiety rats, as seen in Figure 1. However, this effect was not seen with heroin. As this effect was not seen with heroin, these results may not generalize to nicotine, as the effect could be insignificant. Gutierrez et al. Found that nicotine vapor-exposed adolescent rats led to lasting sensitization and active nicotine-seeking behavior later in life. Similarly, the current study expects a significant spike in lever pressing in the nicotine-exposed rats after nicotine cessation, as evidenced in Figure 2, indicative of extinction bursting. This study addresses the gap in understanding how trait anxiety impacts adolescent nicotine addiction, providing preliminary evidence for greater nicotine vapor self-administration in highly anxious adolescents. Future research should explore the neural mechanisms driving these behaviors, such as changes in synaptic plasticity within the VTA. Additionally, studies should investigate potential pharmacological interventions to mitigate the heightened addiction risk of individuals with high trait anxiety. Understanding these mechanisms can inform the development of targeted public health strategies and more effective treatments for nicotine vaping addiction, therefore preventing long-term nicotine addiction and mitigating its harmful effects on health.